There we go. Good afternoon, everybody. I'm in the lab at the moment, and I wanted to give you a little bit of an idea of what you can expect to be doing basically over the course of the next 3 weeks. Over the next 3 weeks, basically I've afforded enough time to purify a protein, your protein, lactate dehydrogenase, from 2 different columns. One of those columns is an ion exchange column, and the other column is an affinity chromatography column. Now, you'll be able to distinguish these 2 columns from one another because of the fact that the affinity chromatography column has a blue resin. Now, let me go ahead and get that so you can see what I'm talking about. So, as you can see here, there's this, and maybe you can't tell really with the colors there, but that is the blue medium or the blue resin that I was alluding to a moment ago. And what you're going to do is you're going to add a portion of your dialyzed protein sample directly to this column. And what that protein is going to do is it's going to slowly but surely migrate through these beads. Now, these beads, and you can't obviously detect, or you can't with the naked eye see those beads in there, but those beads have a small molecule that will enable lactate dehydrogenase to bind to it. So it's going to be based on affinity, based on attraction that your enzyme has for what's immobilized on these beads. The other column has a white resin or a white medium. See, I hope that you can see that. This is the solution that's above it, and here is the medium, or here is the resin itself that will attract your protein, or attract proteins to it. Now, sort of the process of purifying a protein through a column chromatography column is that, and this is really more the logistics of it, the brass tacks, like what do I need to do? What you will need to do is you will use a transfer pipette. That's one of those bulb pipetters that's maybe half a foot long. You're going to use a transfer pipette to transfer your protein sample into this column. Now, I'm going to use my pen as the example transfer pipette. So this is the end, the open end of the transfer pipette. And what I'm going to do, and this might be difficult to tell with the depth of the frame here, but what I'm going to do is I'm going to put the end of my pipetteman against the interior of my column. Once that's in direct contact, and I don't have to put a lot of force on it or anything like that, I'm going to squeeze the bulb of my transfer pipetteman. And what that's going to do is allow the solution that's in my transfer pipetteman to basically fill this column, but it's going to do it gradually and slowly. The most important thing about transferring or adding a solution to your column is you don't want to disrupt the resin bed. If you pour directly onto this, what's going to happen is these beads that make up that medium, they're going to be dispersed. It's not going to be a settled bed. So then basically what you have to do is, well, your sample isn't necessarily going to be moving through the resin, but rather it's going to be settling. It's going to be moving through the column, but it's going to, your bed is going to have to settle as well. So you want to make sure to, and I'll use the clicking of the pen as the squeezing of the pipette bulb, put this in contact with the interior of the column, very slowly but surely eject the solution, and you'll see the solution level rise up. Okay, now as you're doing that, have an eye on basically a water level or a solution level above your resin's bed, or above the top of your resin, or above the top of the bed of the material here. You never want to let your solution go below that. The reason is that will dry out your resin bed, in which case, then it's not going to be as effective. And over time, it's going to deplete it more and more and more. So what you want to be doing is you want to be constantly adding more and more solution. Now you might think, okay, well, we've been given 1 milliliter of a protein sample. What are we supposed to do? You're right. That is not an incorrect amount that you've been given. What you're going to want to do is continue adding your lysis buffer. Continue adding the lysis buffer or your sodium phosphate buffer that has no sodium chloride. Key, no sodium chloride. So everyone's going to start their experiment with one of these right here. So this is a dialysis sample. Now this sample is your cell, or your not cell pellet, but the pellet that emerged from the highest amount of ammonium sulfate. So think about this as you had a big pellet with ammonium sulfate, but within there are proteins. Now what we want to do is we want to get rid of those that ammonium sulfate and retain the proteins. Well, this dialysis tubing is it is porous. It has very, very small holes. These holes are they are so small that anything that is under 10,000 Daltons can leave. But they are large enough so that anything that is 10,000 Daltons or smaller will leave, but anything that is above 10,000 Daltons will stay in this tubing, or will stay in this kind of pouch, in this pouch that we made. So everyone's going to start with one of these samples. They're going to load that onto, they're going to take half of it and put it onto their column, and half of it and put it onto, their affinity column, and the other half onto their ion exchange chromatography column. Now, one very important matter is that there is one of these per section. So you will have to, or your IA will have to distribute that. But keep in mind that if you get 1 milliliter of this sample, 500 microliters goes onto the ion exchange column, 500 microliters goes onto the affinity chromatography column. That's a very important thing so that we don't use more than we have available. Now, the next thing that I wanted to talk to you all about is with respect to your columns. Okay, so what is in this, what solution is in this column right now is your lysis buffer. That's the sodium phosphate buffer that has no sodium chloride. Now, you are going to take the cap and this tip off, and what you will see is gravity will drive the solution through. Now, you will have to keep replenishing with more and more solution in order to get your sample to run all the way through the column. Now, what you are going to be doing for this first meeting primarily is you're going to be measuring the absorbance of your sample at 280 nanometers, okay? So you will collect the solution that flows through here with a microcentrifuge tube, and you will continue collecting until your reading at A280 is 0. Once it hits 0, then you're going to transition from adding the lysis solution to this to now you're going to use the elution solution. Now, the elution solution is that exact same sodium phosphate buffer, but this has sodium chloride in it. Okay. Now, with respect to these columns, there are some things that will maybe frustrate you a little bit. And there's one thing in particular, and that is the flow rate. These columns have variable flow rates, and not by design or anything, but just through use and reuse. They have, some of them flow very quickly, and some of them do not flow as quickly. Now, in order to kind of, and sometimes that's simply a matter of there's an air bubble right below your resin, and so basically everything has to work its way around the air bubble. In order to mitigate that, or to remove that air bubble, or if your solution is running particularly slowly through your column, what I want you to do is use back pressure. And the way that you're going to use that back pressure is with a very complicated device known as your hand. I'm right-handed, so I will use my right hand. And what I'm going to do is grip this, and with an open tip and an open cap, I'm simply going to use my thumb, and I'm going to depress down. I selected my thumb because the surface area of my thumb will cover this opening, and I'll be able to push down and get a little bit of force to drive my solution through that column. So in the event that happens, that's what you'll need to do. And some of y'all might have to do it kind of throughout the purification process. I prefer that you work with basically just letting gravity do the work, but sometimes gravity needs a little bit of help, and so you can offer it that way. I believe that's everything with respect to purification.